let you know when it goes live. All right, give me a second. We're going live in just a second. All right, we are live.
So Martin, let me know if I should reshare my screen now.
Yes, 1 second, I'll give an introduction. Hello, everyone. Welcome to the Research Showcase in March 2022. I'm Martin Gerlach. I'm a research scientist at the Wikimedia Foundation, and I will be the host for today's showcase. The theme today revolves around the quality of articles. So in addition to adding new articles, there's a significant part of the work of editors is maintenance and improvement of quality. And this is crucial to preserve reliability and integrity of the content. The research team at the Wikimedia Foundation is very much dedicated to contribute to this space. The knowledge integrity is one of the three main research programs that we are pursuing, and how to work towards developing efficient and scalable strategies to preserve the integrity of the projects. In this showcase, we are interested to discuss in more detail questions around the development of automatic tools to monitor quality of articles. For example, what are useful patterns that we can leverage to automatically assess article quality at scale, especially when it gets to more difficult aspects such as neutrality or verifiability. The second aspect is that we will be discussing is what is the life cycle of an article's quality over time. And for this, we are very glad to have two excellent speakers today. First, we'll have Animesh Mukherjee. He's professor at the Department of Computer Science and Engineering at the Indian Institute of Technology in Kharagpur. And in the second half, we will have Sumit Asthana, PhD student at the Computational Human Computer Interaction Lab at the University of Michigan. I want to thank both of them for taking the time to share their research with us today. At the end of the talk, or the end of each talk, we'll have time for Q&A. If you have questions for the speakers, please put them in the chat or on IRC. My colleague Isaac Johnson will monitor and relay the questions here. Before we start with the talks, I want to do two quick announcements. One is around Wiki Workshop, our annual venue for research around Wikimedia projects. Registration is now open. Please check wikiworkshop.org, and I will also share the direct registration link in a minute in the chat. And the second point I want to share is that we are inviting you to give feedback on our monthly office hours. So we are holding office hours once a month where everyone can join. And in order to make ourselves more available to answer your research questions. And we would like to improve the accessibility and the usefulness of this venue. Therefore, so we would like to better understand what are your needs, what are your motivations, or your previous experiences. Even if you haven't attended previously, we would still like to hear what prevents you perhaps from attending office hours, or what are barriers. And I will put a link for the survey form in the chat in a minute. And we would very much appreciate and thank you if you could answer a few questions. And with these announcements, I don't want to talk further. I will hand it over to Animesh. Please go ahead and share your slides. We are very excited to hear your presentation.
Thank you very much, Martin. So I'll try to share my screen. Hopefully it's visible.
Yes, we can see it. You want to go to presentation mode?
I guess you are seeing the presentation mode.
Perfect.
So thank you very much, Martin, for this invitation. Like all of us here working at IIT Kharagpur on Wikipedia, like the team together is very excited to participate in this workshop. And today I'm going to talk a little bit about some of the things that we have been doing for the last 4 or 5 years, like we're stressing on two of the key things, which is kind of the theme of today's showcase and centers around quality monitoring. So like we have been working in this space of Wikipedia since 2016, since around 2016, and like we have been working a bit on citation enhancements in Wikipedia reference enhancement, and then like coming to quality monitoring of the article as well as the quality monitoring of the revisions. And I have been like very lucky to have this team of excellent researchers with me who have been like constantly working and putting all their painstaking efforts to make these projects successful. And like all the hard work, believe me, is done by them, and I'm just doing the showcasing. So yeah, so in today's talk, I'm going to mainly focus on the last two works which were recently published, one in 2021, and which also received the best student paper in that conference, and the other is going to be presented in CSEW 2022 this year. So like this is roughly the table of contents that we will follow. Like we will talk a little bit about missing Wikipedians, who are they, like how to detect them efficiently. So that forms the first part of my talk. And the second part is more about the quality change of Wikipedia articles. So this is more like a longitudinal perspective of the data, where we try to understand like what are the indicators of quality change, and is there a possible computational method that can be devised so as to detect quality change. So we start with the first part, like missing Wikipedians. Who are they? Like I guess like to this learned audience, it's well known, but still just for the sake of completeness, I'll summarize like whom we call missing Wikipedians. So in general, like we have an operational definition of prolific Wikipedians as those who have done like larger than 1K edits. And active Wikipedians are those like prolific Wikipedians who are still actively contributing to the development of the different articles over Wikipedia. And missing Wikipedians, like this has reference to the Wiki project miss, are those prolific Wikipedians who have been inactive for more than 3 months. So like an example of the profile page of a missing Wikipedian is cited at the bottom. So like not in all cases a missing Wikipedian actually leaves messages as to like, or leave a retiring message, but there are some cases where you can find them, and this is one case where like the person has indicated the retirement specifically, as well as cited some reasons as to the retirement. So in order to do a little bit further analysis about missing Wikipedians, so we wanted to look at their behavior on this platform, and like we collected around 1146 such Wikipedians from the Wiki project miss, and these are all those who did not have any edit across the entire calendar year 2020. So active Wikipedians, like as I said, like they're also, so both of them are prolific in the sense that missing Wikipedians, when they were active, like actually had done more than 1,000 edits, so that constraint always is there. For the active Wikipedians, like we found out editors or Wikipedians who have very similar activity levels as the missing Wikipedians, and like have kind of contributed to very similar pages as those contributed by the missing Wikipedians. I'm not going into the nitty-gritties, but you can look up into the paper. So there is some sort of statistical sampling that goes on in finding the right set of active Wikipedians with whom we can compare the missing Wikipedians. So, and this way we collected around 2569 active Wikipedians. And now we will try to look into a little bit as to like what are the characteristics of the missing Wikipedians vis-a-vis the active Wikipedians. So, so our hypothesis is that like by looking at the behavior of the missing Wikipedians, it is possible to predict whether an active Wikipedian is going to retire soon. So this is the task at hand. So the hypothesis that we put forward is that the last trail of activities especially is going to leave the signs of retirement for an active Wikipedian. So now what are these signs? So the signs that we typically extracted, as we will see, are based on the activity of the Wikipedian, some linguistic qualities of the text that he or she is editing, and some quality measures of their edits. And then like using this bunch of features as a set of features, we train like standard machine learning models in order to predict whether certain active Wikipedians are at a potential less risk of leaving the platform soon. So like, as I said, we were interested in measuring these three types of engineered features. One relates to the activity, which is like count of major and minor edits, edits in different namespaces, length of the edits, the ORI score of the edits, etc. So these are kind of the activity features. The quality features are like the total number of revers that an edit of a Wikipedian like witnesses. So we have seen that toward retirement, the number of reverts for a Wikipedian actually increases. So this has been one of the very interesting signals, as well as there are certain scores that the Wikipedia community provides, like the admin score, etc., which are also taken into consideration. And in addition, we also looked into some of the like textual quality of the edits that were made by the Wikipedians, like these are like simple syntactic structures, sentence embeddings, and certain like emotional features. Although Wikipedia has this NPOV standards, like there are certain opinionated things that we find now and again on different Wikipedia articles, and this is well captured by the this tool called Empath. So using this collection of features, we trained like standard off-the-shelf machine learning models like random forest, XGBoost, etc., and tried to predict whether certain active Wikipedians are going to be missing in the like near future. So, and what we observed that using this very simple set of features, which are kind of highly explainable, it is possible to predict whether certain Wikipedians are at a risk of leaving the platform with around 82% accuracy. So, and the most predictive features are the activity features and the quality features. So as I said, like one of the top features was the count of the number of reverts. So this actually increases rapidly close to the retirement of a Wikipedian. So similarly, there are certain activity features like the number of minor edits. So what we observe is that close to the retirement, the number of minor edits actually increases manifolds compared to the major edits. So typically people like who are at the verge of retiring only keep on doing minor edits close to the time of their retirement, whereas the major edits are mostly done by the more active editors. And we also tried to deep dive into like some of the reasons for leaving the platform. So we observed that some sort of bullying has been going on in the community, which have deterred many of the active Wikipedians to go missing. So one example is being cited here, but this is not a pathological example. This is representative, and we have seen in many cases where editors actually have left a note as to why they retired. They have put up this kind of harassment complaints. Okay, so that summarizes the first part of the talk. So now I'll move on to the second part, where we were looking, where we were having a longitudinal perspective into the change of quality in Wikipedia articles. And we start off with what are the different indicators of such quality change. So, but before that, again, for the sake of completeness, basically article quality indicates how good a Wikipedia article is, and Wikipedia community itself classifies articles into different quality classes, starting from FA to start and stub. So FA on the leftmost side is the best quality article, whereas the start and stub are the most poor quality articles. And a good quality article is basically adjudged by its being comprehensible, well organized, readable, and well referenced. So this is cropped from Wikipedia website itself, and if you look carefully into the data, what we observe is that there are only a very few good quality articles, and close to 50% of the articles are kind of in the start and stub category. So this was a rising point of concern for us to take up this problem, and we tried to see when does quality change? What are the indicators of the change in quality of Wikipedia articles? So this is typically an example life cycle, again cropped from the Wikipedia website directly. So an article starts its life cycle from being a stub, and then it moves forward, it gets edited over multiple rounds, and over each revisions it improves, and then finally at some point in time it becomes a featured article or the best quality article. So from these observations, we set up two RQs. The first RQ was how do the Wikipedia articles transition through different quality states over time, and the second is how do you envisage to detect this dynamic change in the article quality. So in order to do this, we collected around 30K Wikipedia articles, trying to have a balanced representation from all the quality classes, except for A, which has kind of little less representation also in the overall Wikipedia data. So the left-hand side shows the distribution of the data in the different classes, and in order to make the results more statistically concrete, we kind of join some of the classes so that the number of data points increase in those classes, and also when we look into the guidelines of delineating between A and GA and B and C, we find that the guidelines are very, very fine. So that's why we went on to merge them together, and we now had these 4 classes. So these are the final 4 classes on which we are going to do all our analysis. So now comes to some of the interesting parts. So what we observe is that there are different types of evolution that takes place, or quality class evolution that takes place in the article space. So while some of them are a single step jump, for instance, as you see here, AGA to FA, it's just a single step jump. But then there are some, not many in number, but it's interesting to see that there are some which have jumped from an SS to direct FA. So these are like kind of could be some of the points of interest, like and one could really look into like what kind of activities on the platform resulted in this kind of sudden jump in the quality class. So similarly, like it's not only promotion, we also see there are demotions, and of course the number of demotions are much less in number. So that some of the demotions are like from FA to BC, AGA to SS, like these are like two-step change in the quality class. And also interesting to note is that this change in quality class actually happened in a very short period of time, within a very, very short period of time. So that's kind of some of the interesting points of observation from the quality class evolution. And of course, there are like a large set of articles for which there is almost no change in quality. Like they started off with one quality and they stayed there in that quality class for the rest of the period of their existence. And what is concerning here is that the largest share here is contributed by the SS class. So for this class, actually, we see that change in quality is extremely, extremely slow. And like in most of the cases, as we see, like almost 1/3 of the pages that we collected, like these articles do not experience any quality change. So looking into a little bit more detail, so here we kind of plot the more microscopic transition of the quality classes starting from 2010 to 2019. Like we break it into two parts for a specific reason. So what you see here is that like in the first 5 years from 2010 to 2014, like there has been at least some good amount of jump from the start-stop class to its higher class, okay, to BC, at least the BC class. But this trend seems to be declining in the latter years. So this seems to be more concerning. So while in the previous slide, I showed you some aggregate results, this microscopic result seems to be a little bit more concerning to me, because while in the earlier years, we saw at least some fraction of jump from the SS class to the BC class, this actually has reduced drastically. This fraction actually, if you see, has reduced. The lines have become much thinner here, have reduced drastically in the next 5 years. So there is something problematic going on there, and probably it's worth looking into more details in this space. So another interesting thing that we observed is this cyclic switches. So what happens is that some articles actually undergo cyclic switches like this. So maybe it was in the beginning in a featured article, then it suddenly became a B, and then it again became FA. And like on the left hand side, I'm showing you some articles who have like experienced different numbers of cyclic switches. So, and as you see, like there are certain articles who have experienced 9 cyclic switches, 9 length cyclic switches. So basically it started off with one quality class, jumped to another, again came back to another quality class, and there were 9 such switches until it came back to its original class. So, and on the right hand side, we see some of the classes which experience a lot of cyclic switches and in a very short period of time. So within less than 15 days, you see like a lot of cyclic switches that happens between these sets of quality classes. So we were wondering, like as people had heard about edit war and have been working on this for a long time, whether there are cyclic switch wars also. And we observed, when we delved a little deeper, we observed that there is actually reason to believe that editors are switching the quality classes in the subsequent revisions, which probably has resulted into this kind of cyclic switches. And at some point in time, someone has to look into more details to see how interventions could be, appropriate interventions could be placed in order to like have a more meaningful quality class assignment for a particular article. So coming to the last part of the talk, like where I'll be talking a little bit about like, okay, we have seen qualities changing. So is there a way to detect this quality change early in time? So what we observe is that when you look into certain features like the average number of editors on a particular page, or the average number of revisions that a particular page experiences, then you see certain trends like over time specified in months. If you look into the distribution of these two numbers, you see, and you plot the change point, then you see close toward the change point, there is some change also in the nature or the way the plot looks like. So basically, our idea was like using this simple set of features, whether one can, capture the change point. And we went into the CS literature and we saw, okay, like there has been some work in this space, and this relates to multivariate change point detection. And we use some standard, again, off-the-shelf models for multivariate change point detection. And we used some features. Some of these features are based on contribution of the editors, like registered editors on the talk page, registered editors on the article page, etc. Then we have the content-based features like article length, references in the article, hyperlinks in the article, whether info box is present or not, etc. And in addition, we measure certain linguistic features like the readability of the page using certain readability scores. And then there are the activity features like mean variance time between two consecutive revisions of the talk page, of the article page, number of revisions that the talk pages have experienced, number of revisions main pages have experienced. And from these, like over the different revisions, we actually create feature vectors constructing a multivariate time series. And using this set of features, we finally feed them into the change point detection models. So as I had noted, like we use 3 different change point detection models. And what we observe is that the content-based features, like those related to the number of citations, references, article length, etc., actually are the best indicators of the change point. And like when we use an ensemble of all these 3 methods, we actually do much better than the individual methods. And we also try to compare our method with the standard method provided by Wikipedia, that is ORIS, and we observe that our hybrid method actually does better than ORIS for two different choice of data sets. One sample was like there is at least one change point in the ground truth data, and the other is like the articles got at least promoted once to the FA class, because that is the the dream class for every article, so to say. And we observe that there are like certain important features which actually are more predictive in identifying the change points. So like these are the mean and variance of time elapsed, revisions of talk pages, revisions of article pages, presence of difficult words. Like this presence of difficult words actually is a very important indicator, and the less difficult word page has, we saw the higher the chances are of it being promoted to better classes. So this is roughly the whole set of work that we have been doing in the article quality monitoring of Wikipedia, and I'd stop here in the interest of time and would be happy to take questions. I hope I have not overshot.
Thank you so much, Animesh. You're perfectly on time. Thank you for the great presentation, for the different aspects of the work you do on quality. I invite everyone to, if you have questions for Animesh and the team, feel free to ask them in the chat or on YouTube chat or on IRC. In the meantime, I think at the moment we don't have any questions yet. I'll pass it to a room if anyone has any questions, and if not, then I will go, but I'll give the chance.
Hey folks, can you hear me?
Yes.
Yes, I can.
This is Aaron Halfaker. So one of the questions that I had about these transition states, so I imagine like an article transition. Sorry, my daughter's with me here. But an article transition is the point at which somebody edits the top page to say that the article has transitioned from one quality to another. Am I understanding that right?
Yes.
So I wonder if like the features of activity on the top page are essentially measuring the edit that changed the quality level as denoted in the top page. You know, and I wonder too, like one of the processes that we went through with ORAs is that we'd actually run ORAs over a large set of articles and telling people like, hey, the prediction is different from the label. You might consider updating the label if that's appropriate. And that was actually a common pattern. So usually ORAs actually precedes when the label gets switched, but not when the label should have been switched. And so I wonder how you think about that when you're exploring these sort of transition points. Like, when is the real transition point? Is it when somebody changes the label or when somebody should have changed the label?
I would say that we get the label as soon as like it is reflected in the talk page. Like as soon as it is reflected, as soon as somebody changes the label on the talk page, like we assume that that is the point at which the label has been changed.
Right. I guess what I'm saying is that a good assumption?
Okay. So I'm not sure. Is there a way to get a notion of like what would be the best time when one should extract the label? Like whatever is available on the talk page is what we could gather. So if there is a better way of like getting access to the exact point where one deems that the label has changed, then we would be happy to experiment with that. But my take would be like the overall trends that we observe here are not going to change much.
All right. Well, I could imagine a few other mechanisms, but I'll sync with you offline.
Sure.
Animesh, I had a question about your first set of projects around the missing Wikipedians. You talked a little bit about folks leaving kind of in protest or around kind of harassment. And I wondered what features, did you have any features that seem to be capturing kind of burnout in general? And if you could talk to whether that showed up in your data or not.
Yeah, yes, I think like we used, so as I was telling you, like we used some features, some linguistic features related to the emotions and like which could capture the emotions and some sort of sentiments of these people through the empath analysis. So that's what we did. But I think like what is more meaningful is to extract all the revisions that these people have done and all the comments that these people have posted on the talk pages in order to do this empath analysis. That is something that we have not done because that becomes extremely compute intensive. But you are right. So like if one does that, probably one would get like even better signals of the burnout. So our idea was to, keep the whole thing very lightweight and to get an indication of, so this, as you understand, so this is a reverse step. So once we identified these editors as potential missing editors, we went back into their profile page and looked and saw. So this wasn't like a post facto error analysis that we were doing, kind of like insight analysis that we were doing. We did not have a plan to pump this as a feature into the model to do better predictions. But of course, that's a very good point. So, but then there are two caveats here. One, as I said, is that most people are very shy. They do not leave such signatures. So there are only a very few people who tend to leave such blatant signatures on their profile page before they retire. And the second thing is delving into the profile page of each editor after each revision that they have done, that actually is kind of, so that was actually a bit bothersome for us from the perspective of crawling the data or acquiring the data. But we can definitely sync up with you and try to do something like if we get access to this data, say in a little more simpler, with a little more simpler pre-processing, then it might be a good idea to work on that.
Thanks.
I have a follow-up question, Animesh. It's a very interesting finding that so few articles increased in the quality scale, from what I understand. Have you had a chance to, or I wonder if you have an idea or looked into some specific types of articles? I could imagine that, what comes to my mind is that there's many campaigns that try to improve, not just to add new articles, but improve collections of articles on a specific topic by adding information, adding images, and so on. And if you have potentially, or from my perception, these types of activities are increasing. There's more and more of these types of activities. And I would, my assumption would be that this type of activity would be reflected in those articles, also improving the quality, skills. So maybe overall, there's so many articles being added that this is still a small fraction, and it's not it doesn't compare in the scale. Or what are your thoughts if you had the chance to investigate?
Very good question, Martin. We indeed had a chance to see through some of the articles which actually got promoted, as I was showing you. So there are a very small set of articles, but they got promoted from SS directly to FA. Paramita, I know that you had seen the data more closely. Would you like to take up this question from Martin?
Yeah. Hello, I'm audible?
Yes, you are.
Yeah. So
sorry, just a quick question, Animesh. Could you unmute your not unmute, stop sharing the screen so we can see the.
Sure.
Sorry, go ahead, Paramita.
Yeah. So so we actually show few articles that just directly jump from essays to FA, and when we just collected the quality level at that particular point of time when it was SS, and then it was continuously just the quality level was SS, and then suddenly it was reached to FA. Before, we know that before FA promotion there was some kind of going through some review process and then some kind of review committee, but ultimately it is promoted to FA. So this is kind of observation we have seen nowadays.
So I think Martin's question was are there some specific example pages which you can recall?
Okay, example pages. So mostly we have observed the American movies. These movies, Living People. So these kind of pages were the maximum majority in our data set. But those actually, this SS to FA pages are very few in number. So exact that article name or the article page.
If I recall, some of these were political articles. Some of these were political articles,
and
So I think like there was one article which was about the like about some political campaign that was going on, and it was around this political campaign like that was not very popular in the like in the earlier times, but suddenly it picked up. So that political campaign picked up, and then it became viral. So I agree with you, Martin. So there is some sort of virality of the topic that actually like promotes or pushes the article quality. And I think like in fact I was like I'm involved in some other work where we were seeing that this in fact has connections not only within Wikipedia, but it's a cross-platform influence. So basically certain things become very viral, say in Twitter, and suddenly the Wikipedia page starts getting more traction. And like from there onward, people start collaborating and writing a lot on that particular topic under that Wikipedia article, and the quality gets like changed. So as Paramita was suggesting, like most of these articles, which you see is kind of, you know, a sharp transition that is happening. Like it's like SS, 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 and suddenly there is like this FA. So so basically it's like a step function that one observes. And this step function is like, I would say, mostly associated to some sort of a virality in the topic space that probably is not limited only to Wikipedia, but also like across other platforms where probably the topic has become very attractive, and then slowly it dragged a lot of attention, and the Wikipedia article also got edited therefore.
Great. Thanks so much for the answer. I think if there's further questions, we can revisit at the end of the showcase, potentially. Thank you for now. I think it is time to move on to our second speaker. Sumit, please share your screen, and another reminder that if you have questions for either Animesh or Sumit during this talk, feel free to post your question in the chat. With this, Sumit, go ahead.
Thanks, Martin. Am I audible?
Yes, loud and clear, and we can see your slides too.
Okay, thanks. Let me start. Hi, everyone. I'm Sumit Asthana. I'm a third-year PhD student at University of Michigan, CSC. And I have also been a volunteer with Wikimedia Foundation, with Wikipedia since 2015, contributing as a developer and also in research. And today I'm going to talk about our work on automatically labeling low quality content on Wikipedia by leveraging patterns in editing behavior. So while my previous speaker talked about quality of articles at a higher level, I'm going to delve deeper into more fine-grained aspects of content quality on Wikipedia. So Wikipedia as an encyclopedia aims to be one of high quality with well-written, grammatically correct and neutral articles. So to quantify article quality, Wikipedia editors, specifically English Wikipedia editors, came up with a 6-point quality scale ranging from the most basic stub articles to the most comprehensive featured articles on Wikipedia. And this graph shows the distribution of their assessment of about 95% articles on English Wikipedia on this 6-point quality scale. And we can see that most of the mass of articles is situated on the stub and start class. And while we agree that not all articles in the stub and start class merit improvement because they might not be significant enough, but still if mass of this distribution shifts more towards the right, towards the GA class, Wikipedia can benefit a lot and the readers can benefit a lot from quality improvement. And other Wikipedia language editions also have similar quality scales, and the articles are also following a similar distribution. Now, the major problem with the Wikipedia's article quality that we saw is that there are too few editors to monitor, assess, improve, and promote these many number of articles on Wikipedia. Looking at it more carefully, so I'm presenting a very sort of simplistic way of how article improvement works in Wikipedia, though processes are much more complex. So let's suppose someone comes along and edits an article by adding some new content. Then another editor comes along and reviews the content that is already added by the previous editor. And this content could be reviewed either on the recent changes feed or on the top or on their just through browsing. And the editor may decide to add their own content. They may decide to improve the content of the previous editor, or it could actually also be the same editor following up on their edits to improve the content in the sense that rephrasing content to make it better, following style guidelines, following citation guidelines. Now, the major problem with with this whole process is that the process is entirely manual right now, and especially the reviewing aspect, because reviewing is a non-trivial job in the sense that when someone has to review someone else's content, they have to look at each of the sentences and they have to take a judgment call on whether these sentences satisfy the quality guidelines of Wikipedia and Wikipedia standards. So this is a very cognitively demanding process. So the question is that can we do better? Can we help editors in some aspects? A natural answer to that is that we can use automation to offload the burden on editors. So ideally, if we can get suggestions for exact sentences that need improvement, and also what kind of improvements can we make on sentences, it saves a lot of time for other editors as well as for the editors of the for the current editors as well as reviewers who are reviewing someone else's edit. So while existing approaches have used supervised machine learning to predict quality at an article level and to tackle some aspects of quality like vandalism, but predicting which sentences need to be improved as shown here and what improvements need to be done still remains a big challenge. And in the rest of the talk, I'm going to talk about how learning from Wikipedia edits allows us to detect such sentence level issues. Let's review why existing supervised machine learning approaches sort of do not allow us to get there. So typically these approaches start with creating positive and negative examples for a task. And a task could be like vandalism detection, and a positive example would be vandalizing edits, and negative examples would be regular Wikipedia edits. And a training data is constructed from such edits. And this training data usually comes from either crowdsourcing, or it could come from the highest quality featured Wikipedia articles like articles which have the highest quality class, or it could also come from labeling by Wikipedia editors, but which is sort of very time demanding on Wikipedia editors. And this is followed by training and testing the classifier with this label data to perform that task, like whether an edit is a vandalism edit or not, or predicting the quality of an article. And it could further be validated based on past research datasets. And finally, when the machine learning model has been sort of tested enough, it could be deployed to Wikipedia to assist editors. However, very few approaches have seen such kind of large-scale deployment of the Wikipedia ecosystem, because it's challenging to deploy a model which can assist editors and which can work at such a large scale and have everyone on board. And most of the approaches are still in the testing phase. So the main limitation for these approaches towards obtaining good quality label data for sentence improvement, like the kind of goal that I showed before, is obtaining the way that the labels are obtained. So this is because identifying sentence issues such as sentences that require citations, clarifications, or fixing neutrality requires labels at the sentence level. And Wikipedia editor does not provide us an interface to flag such issues while we are editing. And templates like citations needed have limited coverage. Further, crowdsourcing quality tasks could produce noisy labels because crowd workers may lack knowledge about Wikipedia policies on content quality. So in this work, we propose a labeling approach that leverages implicit editing behavior to automatically label the quality of Wikipedia's sentences. So our approach allows us to learn from any kind of non-reverted Wikipedia edit. So we first use regular expressions to label the semantic intent of non-reverted Wikipedia edits, such as which edit is adding a citation, which edit is fixing a grammar. And then using these semantic intent labeled edits, we obtain positive examples of sentence quality improvement, such as sentences in edits where citations were added, or which sentences was grammar fixed, or which sentences were rephrased to be more neutral. And we obtain corresponding negative examples of sentence improvement from highest quality featured Wikipedia articles based on insights from existing work. And these insights suggest that because featured articles have already gone through an extensive review process, most of the sentences in such articles are almost close to being perfect. So we can use them as examples which do not need improvement. And finally, we can train the rest of the machine learning model as I described before in the process. Very brief aside on regular expressions because I talked about them. So regular expressions are patterns in computer languages that allow us to test the presence of and extract pieces of text from large documents. So for example, in the first case, if you wanted to extract the text 1948, we can use a pattern shown on the right. And in the second case, if you wanted to extract the string, let's say citation needed, or test the presence of citation needed template, we can use something as given on the right. So these patterns are a very good way to sort of extract meaningful or interesting pieces of text from large documents. Coming back to our original goal now, consider this Wikipedia sentence. So our modeling approach allows us to answer questions like, does this sentence need fact updates? Does this sentence have a point of view issue? Or does this sentence need clarifications? Or does it need to be simplified? So the basic idea behind the approach is that many Wikipedia edits are performed with a specific intention in mind. Example, adding citation, removing bias, or clarifying content. And sentences modified in such Wikipedia edits can be used as positive examples of sentence improvement. And the semantic categories that we look at to demonstrate our approach are citations. They've also defined as adding a citation. Point of view, also defined as rewriting using encyclopedic or neutral tone and removing bias. And clarifications, that is specifying or explaining an existing fact or meaning by example or discussion without adding the information. So first of all, the first step of our approach is identifying the semantic intent of an edit. And to do that, we test the edit against regular expressions on three parts of the edit. The first is the edit comment, which I've just highlighted here at the top. The second is the sentences before the edit was made. And the third are the sentences after an edit was made. And if all the regular expressions match for the given intent, we assign that specific intent to that Wikipedia edit. So for example, in this case, we say that, let's say if a reference tag is present in the inserted portion of the edit, we can assign the intent citation to this Wikipedia edit because it's attempting to add a citation to a sentence. Now, it's important to note that most of the Wikipedia edits are very noisy because noisy in the sense that there is a lot going on in these edits. There could be citations, there could be rephrases, there could be grammar fixes, there could be a lot of other things. But in order to extract their data that can be used to train models like detection of citations or detection of neutrality, we need to extract as much precise data as possible. So in order to do that, we eliminate noise by making some more exclusions, like excluding edits which have templates inserted or deleted for the citations, excluding edits which have wiki links, info boxes, or multi-lines inserted or deleted. So after using all of these regular expression rules on a set of Wikipedia edits, what we are left with is a set of very high quality edits that only add citation to the in the edit, and that we can use as examples where citations are probably needed. Now moving on to the second part, that is once we identify the intent of a Wikipedia edit, we can assign a quality label to the sentence that was edited, indicating that it needed that edit. For example, in this case, we have the intent of the edit as citation, and we can say that this sentence that was edited in this edit potentially needed a citation, so its needs citation level can be set to 1. So in a way, the intent of the edit is implicitly allowing us to make claims about the quality of the sentence in an article, which would otherwise have required a human to assess and label. So to evaluate a regular expression-based intent labeling, we actually worked with 10 Wikipedia editors and asked them to assign semantic intent labels to about 450 Wikipedia edits. They had an average experience of 10 years, and we compare the ground truth labels by Wikipedia editors to the predictions of our regular expressions to compute precision and recall, which you see on the y-axis, for the three categories: citations, point of view, and clarifications on the x-axis. So very briefly, precision means that out of all the edits identified as citations by regular expressions, how many edits were actually citations? And recall means that out of all the citation edits that we had in our data set, how many citation edits were the regular expressions able to catch? So the precision of our rules is fairly high, which means that a high percentage of the examples that are regular expressions marked as positive are correct. This is important because as we are trying to get many examples of Wikipedia sentences that need improvement, but without introducing too many false positives. We can also see that the recall is low, which means that we did not catch a lot of positive examples of the total annotated as positive. This is fine because as long as we have enough clean positive examples from the millions of Wikipedia edits we are extracting, we are going to be able to train our models effectively. We further investigated the low recall and found that editors had considerable disagreements in their labels. So they had variable interpretations of semantic categories like what does it mean to add a citation? Is date modification in a citation addition of a citation? And also the underlying content was subject to multiple interpretations, especially with regards to the point of view category, because point of view is a neutral point of view is a highly debatable category across all Wikipedias. So people have contentions like, let's say if, an article is describing historical war, people might have contentions about the title, like some group of people might say that we should use the word attack, whereas another group of people might say that we should use the word liberated because the war is liberating someone. So these kind of like conflicting viewpoints lead to these multiple interpretations with regards to neutrality. So after evaluating the edit intention labels, we also evaluate the sentence quality labels that we extract from Wikipedia edits. For example, when we said an edit is a citation edit, and we said that the sentence needed the citation, we need to make sure that these are actually sentences that need citation, or these are actually sentences that are non-neutral, so that high quality models can be trained on them. And because asking humans to manually label the quality of Wikipedia sentences is challenging, we train machine learning models with these labels and compare the models when trained on existing labeling approaches. And we demonstrate our approach to detect which Wikipedia sentences need citations or which Wikipedia sentences have a neutral point of view issue. And we show that our comparison in the paper. And in the example that I've given, the highlighted words also mean that which are the potential words that are causing the model to say that this particular sentence needs the citation. For example, in the second example, Sharky and George was a very popular humorous show about two fish private detectives. Very popular humorous is potentially causing the sentence to have a point of view issue because a very popular word is something that is an added modifier in according to Wikipedia neutral point of view policy standards that we do not need. Now, having described our approach of how we learn from Wikipedia editing behaviors to label sentence quality and train models that can actually predict which sentences need citations, which sentences need neutral point of view edits. Let's look at what does it actually mean to learn from such behaviors, and what does it actually mean to build these AI systems that can help editors detect such issues. So first of all, our data labeling approach is fast because it does not depend on human annotations, rather the activity of Wikipedia editors themselves, which has been ongoing since about 20 years. The approach is also flexible because Wikipedia editors can inform changes to regular expressions based on their domain knowledge. And these sort of feedback are fairly easy to incorporate compared to, let's say, complex machine learning models where domain knowledge adaptation is a little bit difficult. And the approach also does not use any language specific model, only regular expressions, which can be informed in other language editions, making it language independent. And on the other hand, also let's recall the article add, assess, and improve cycle that I described right in the beginning, that someone adds the content, someone else or the same person reviews the content, and then the content is further improved. What if we have an AI that is helping us review this content, that is helping us speed up our job of improving the content? What implications does it have? So a very concrete example of such an assistance would be assisting new editors on common practice, that is recommending best practice changes to new editors, which has been a potential problem in the sense that if new editors already get guidelines of like where to add citations or where to consider sentences for neutrality, or even predicting or even giving them links to sort of neutrality guidelines or citation guidelines, it actually prevents a lot of additional work for a lot of people because it's less work for newcomers who are actually getting recommendations within the editor themselves, so they don't have to follow up on their edits and make changes, read on the guidelines later on. And it's less work for the other editors also, experienced editors, because experienced editors have to like sort of provide guidelines, provide education to the newcomers, whereas now it's all happening inside the editor itself. So all in all, it's kind of saving time for everyone. What we need to do ensure is how we validate these models and how do these models work together with humans. And assisting new editors on common practice, what I just described, or encoding common practices into editing experiences, is actually an ongoing conversation. And this is a sort of feature task that I have shown in this slide. And just to show that how this problem is being thought of right now, and it is a pretty relevant problem. And our user study with Wikipedia editors actually pointed to some interesting challenges with semantic categories. That is that they can have multiple viewpoints. Example, neutrality is a highly debatable policy. And when we are learning from Wikipedia edits, the models need to incorporate such ambiguity. What this means and what questions this raises for us is that when AI systems are actually working together with humans on, let's say, curating something together or helping humans curate something, what kind of effects does it have in the whole ecosystem? Like an AI system helping reviewers review the content of the article. What happens when AI systems disagree with editors? Do we just brush aside the predictions of the AI system as wrong because it's a machine? Or do we actually deliberate on the sort of predictions, saying that, okay, if the system predicted this as non-neutral and we think this is neutral, what could be the potential reasons for this prediction? Can we refine them, just like we would debate with a human that what are the reasons that you're saying so? So these are some very interesting challenges that a lot of people are looking at, and I have just provided a reference citation for more information. And finally, models trained on implicit editing behaviors capture descriptive behaviors, that is how editors interpret and operationalize Wikipedia norms and practices. Therefore, we can use these models to understand the application of a policy in context, like looking at the prediction of new sentences to understand the policy better. What I mean here is that consider this neutral point of view policy on English Wikipedia shown on the right. One way for, as a newcomer, let's say if I have to understand this policy, I can go ahead and read the policy document. I can make sense of what arguments are posted in the policy. But as a human, as any human, I would be more convinced, I would better understand the policy if I were to converse with someone and I were to ask, hey, can you tell me what does neutrality specifically mean in terms of examples? Can you give me some examples of non-neutral and neutral sentences? But it turns out that we might not have access to such an experienced person who can help us out. What can we do here? We can actually use an AI system or a model which is trained on neutral point of view edits from Wikipedia, and which potentially captures some notion of, or potentially captures what it means in Wikipedia practices to be neutral, and run that model on a bunch of sentences that we're interested in. And then we can examine the model's predictions and try to understand that what does neutrality really mean? Does using the word very make something non-neutral, and in what context? We can make sort of these analysis through these models, and we can, so in a way it allows us to probe these norms of Wikipedia using such models. And finally, what do we really need to build better AI? We need, first of all, we need better data to build better AI. And how do we really get better data? Well, we can get better data through more expressive user interfaces. So let's just say that, so right now, the Wiki editor does a phenomenally good job of helping us sort of, let's say, write articles on Wikipedia or do what we are supposed to do. But what if it also allowed us to mark our intentions for a change? Like, let's say, are we doing a neutral point of view change? Are we doing a clarification, especially if we are making small changes? These kind of more expressiveness in user interfaces for people, and also which does not add a lot of work for people, can actually help us build systems which capture what people are doing and what does it mean to make certain edits, what does it mean to make improvements, and then identify that, okay, which kind of sentences need to be improved, what does it mean for a sentence to have non-neutrality, what does it mean for a sentence to be not clarified, so that in future it can learn from those previous edits and it can support editors in future in better sort of speeding up the workflow, so that editors can spend their valuable time on more important tasks, like let's just say adding more content or refining content that's much more complex to handle, like refactoring changes. And with this, I end my talk, and thanks everyone for listening to my talk.
Thanks so much, Sumit, for this presentation. Very, very exciting results, very exciting work. We have time for questions. If you have a question for Sumit or for Animesh from the previous talk, feel free to put them in the chat on YouTube or on IRC. Otherwise, I will open up. I'll start with the room here. Just if you have a question, raise your hand or just unmute yourself and ask the question.
Maybe, sorry, maybe, hi, it's Miriam here. Maybe I can ask something. Thank you so much, Sumit and Animesh, both of you for the presentation. Sumit, maybe you're aware of that. We've been doing some work in the past around trying to detect sentences needing in citation. And so it's really beautiful work, what you've seen, what you've done here. A question that people has often asked us, and that actually I see applicable also to other dimensions that you're exploring, like neutral point of view, for example, is the context of a sentence is extremely important when we're trying to judge whether basically the quality of that sentence. Then you can operationalize it as you want. And I know, I mean, modeling the context is so difficult because of its complexity, its evolution. So I was wondering if you thought about in future work how to include more context into these classifiers, or if you're already doing it and I missed that in the presentation.
Hi, Miriam. Thanks for that question. It's a really good question. So to answer a question on context, in our own work that I have talked about, we already use context at the sentence level, that once we have the labels of which sentences need improvement, we sort of use those entire sentences in these models as positive and negative examples to say that, okay, can models learn to differentiate between good quality examples and bad quality examples, and tell us that, hey, this new sentence is bad quality and potentially needs improvement. But I agree with your point that in neutrality and specifically more complex aspects of it definitely need more context, in the sense that we potentially need to include content at paragraph level. Can we detect more sort of nuanced aspects of neutrality, like people deleting entire paragraphs or people rewording entire paragraphs? This is a more challenging aspect, because I also saw in my own modeling approach that we can potentially detect neutrality at sentence level where minor changes are made, or where people have deleted or added a few words. But at the entire sentence level, if a paragraph is not neutral, we need to incorporate that information in the model. So yeah, that's how I have thought of it as future work. But maybe we can include some more context at the level of an entire article, like what is the situatedness of article in the space of topics? Is it a political article? Is it a sort of science article? That could also provide us useful information. But yeah, that's like a kind of an interesting question, that how do we incorporate such multi-model information or external information to that specific, at least, paragraph? But yeah, in this work we focused more specifically on at the edit level or at the sentence level, how can we do it?
Yes, and it's already, and you know, I know how much work you need to get there. So that's why I was asking more about future work, especially for citations. I'm thinking also for clarification, some information about the surrounding text surrounding the sentence could be helpful. Maybe, you know, looking forward. So yeah, I'm looking forward to see your future work. Thank you so much.
Yeah.
Animesh, you have a question. Go ahead.
Hi, Sumit, can you hear me?
Hi, Animesh. Yes, I can hear you.
Yeah, so just following up on Miriam's question. So I was just wondering, like, one way of incorporating context could be like looking for the info box. So did you have a chance to see like if this kind of information could help in further getting better prediction results? Because why I'm telling this is like in 2020 in an EMNLP paper, what we saw is that the info box information actually, and also the location of the info box information, etc., could actually form like very vital contextual information in different predictive tasks.
That's a good point, Animesh. Actually, right now we did not look at the info box. I mean, incorporation of info box as an external or as a additional signal. But I would be interested in following up on the paper that you are referencing as to how we can actually structurally incorporate information about article, let's just say, to actually detect various kinds of uh, things about articles using info box information. Because I know that info box captures a lot of information about articles at a high level, like probably what the article is about, what it entails, what kind of things are mentioned in those high level statistics. But yeah, in this work we have not incorporated info box, but it would be an interesting thing to look at, like how to do that.
Thanks.
Quick question, Sumit. Could you stop sharing the screen? Then it's easier to see who's talking.
Yeah, sorry.
No worries. Anyone else in the room has a question? Otherwise, I would. Sorry, go ahead, Miriam.
No, I don't want to have a second slot unless there is space for that. So please go ahead.
I had a question. What I found interesting about the classification of or detecting neutral point of view or issues with neutrality. Also, because I think it's probably it's a very hard problem, and I just wanted to ask if I understood correctly that it seemed your precision was very, very high for this task, but that the inter-rater agreement was almost zero. This is what I saw. Maybe I understood this wrong. And I was curious how you interpret this in terms of whether this prediction or a model like this is useful, or how it could be used in practice if different raters don't agree on the output of this model. I imagine that this is maybe the solution would be, or the conclusion is then to say, okay, it's maybe not possible to automatically detect issues with neutrality. I would be curious to hear your thoughts.
Hi, Martin. I think, yeah, thanks for that question. That's a really interesting one, because we also kind of took note of this, and we debated that how can we incorporate such aspects and such models which have decent accuracy, but like which have low inter-annotator agreement. So when we were evaluating these edits for precision and recall and inter-annotator agreement, we wanted to validate whether regular expressions are working well or not. But when we are sort of using these AI systems in practice, especially on Wikipedia, let's say, definitely these kind of low agreement problems will come up, that models might say one thing, editors may disagree. But then we also know that editors disagree amongst themselves because people are coming from different backgrounds. And it's a very interesting question that I have been trying to ask myself, ask others, that when we use these systems in a collaborative environment where people with different viewpoints can come, how can we still have a debate around these issues? Like just like say, if we were not to have an AI system, we still have debates around issues. We still have people who give forth their opinions, and then finally a consensus is reached. How can we still preserve that or have a meaningful discussion which leads to a consensus, which leads to a prediction that makes sense for everyone, but still which saves time for people through these predictions? Like, we could say that this is non-neutral, but hey, these are the possible reasons that this does not, is that we are considering this as non-neutral. This would go into the more explainability aspects of the model, like what are the possible reasons that this classifier is saying that this is not neutral. This could help editors reason out that, okay, yeah, that makes sense, okay, this is probably the reason, so we need to consider this, or we do not need to consider this. But I agree that a black box prediction, like saying, hey, this is non-neutral or this is neutral, is just not doing justice to the content, because in such a multilingual setup, it does not make it, we do not have just one clear viewpoint which wins over the others.
Thank you. Yeah, I think it's a very good, difficult problem, but it makes it exciting too. Isaac, you're saying there's a question from YouTube.
I think Aaron might have had a direct reply to the past question.
Ah, okay.
Yeah, I was just
Aaron?
hoping to chime in just for absolute clarity. So like the low iterator reliability was really in like checking one of our methods, which definitely calls into question like how much people agree on notability. But when we apply these models, there seems to be like a much higher level of consistency. We don't suffer as much from the data quality issues once we learn to model how notability point of view shows up in a sentence. But like one thing that I should say, and so I was one of the Wikipedians who was like looking through these examples. One of the things that I think that we struggle with is that people don't really understand the policies on point of view. Like there are clear examples of point of view issues where we would have editors disagree, and we could go directly to the manual of style that says, no, actually these words are problematic. And we'd go through a discussion, and after a discussion, we would come to an agreement. But I think that there was a lack of understanding of how certain policies might be applied, which I think calls, for this type of modeling work to sort of help people understand how they might apply a policy in context, but also whether those policies should be stated the way that they are in the first place. And so in a way, like applying this model at all, is a great way to start that conversation.
Thanks for clarifying. Yes, totally agree. Makes sense. Isaac, you want to go?
Yeah, Sumit, we have a question from YouTube from Mikal, and they say, thanks for the paper and the talk. And they're curious if you have other proposals around, I think, kind of the curation and like organization of how to detect these issues and how to prevent these issues from showing up in pages, Wikipedia pages.
So I do not have immediate proposals as of now, like right away, that what could be like turnaround curation or improvement. But yeah, definitely extending this work to detect more nuanced aspects of content quality, or like extending this work to detect more challenging aspects, like what does it mean to simplify something to make it more readable, is a sort of direct extension that I can think of. Like readable in the sense that if good article class or feature article class sentences follow some patterns of readability, can we detect those patterns in low quality articles, and can we improve them? And I guess other than that, I'm also looking forward to, like, I guess, interesting conversations always, that what can we do more around this sort of quality aspects, because volunteering for Wikipedia, I know that quality is a very big challenge around the whole ecosystem, given the number of articles that we have.
If I can do a follow-up too, I really like this work. I'm also aware as a researcher that there's certain types of tasks that we might want to model that are very hard. So I really like the approach you all take in this work. And I'm curious if there's certain kind of quality issues or things like that you found it very difficult to build heuristics around and would need kind of much more explicit data in order to model well.
Yes, that's a really good question, in the sense that I did find a number of things, or I did find actually simplifications to be very difficult to heuristically model, because simplifying texts is defined in the Wikipedia sort of semantic category definitions as making it more readable, but to speak in very short. But what does it mean to simplify in a heuristic sense? What does it mean to simplify something if you were to, let's write regular expressions to catch that in edits, is something that I found very challenging, and that probably seemed very difficult at the time. And this seems a very interesting sort of next step, that, okay, can we detect such kind of simplifications, as I mentioned before, an example of readability. And also, like when people rephrase entire sort of paragraphs to remove neutrality, that is also something that probably we need more complex models to detect. And I guess to extend on the last answer that I gave, when we are unable to sort of detect these more complex improvements over time, using these else regular expression patterns. I'm very interested in exploring that. Can we have better user interfaces that do not burden Wikipedia editors to sort of give their opinion about what they're doing, but still that effectively capture, maybe in a very low cost manner, that okay, maybe I'm trying to do this, so it just gives me a suggestion to click right at the end where we are inserting edit summary. So which can we can use as labels in these models to improve them. But that would be a very interesting human-computer interaction challenge. That how do we build these user interfaces that that do not add a lot of cost, but at the same time we get these models to run, we get these to train these models that can help editors in the subsequent future tasks of article quality improvement.
If I could chime in that space too, I think that like one of the things, like we're really only classifying here, so we're really only pointing out problems. But there's a whole class of models that are getting really popular right now, these transformer models that can write text. And so presumably if we had the right kind of data, we could train a transformer model, not just to suggest that a sentence had an issue, but also to suggest how you might rewrite it to address that issue. And that's something, in order to do that, we would essentially need problematic sentence and repaired sentence pairs. And that's something that we don't have right now. But so Sumit showed like a mock-up of an interface at the end of his talk that showed how we could have people show us what they intended to do while they were editing in a more explicit way. Something like that would allow us to start predicting like how to fix sentences, not just whether they have problems or not.
Thank you both. That's yeah, a lot of food for thought. So I think we'll be talking. I know Martin is thinking a lot about readability as well. So hopefully there's something we can do in this domain.
Yes, I agree with Isaac. It seems there's a lot of opportunities. I think with this we are at the end of the showcase. I want to thank again very, very much Animesh and Sumit for their presentations here, for joining us and sharing what they have been doing, their great results. Thanks again. That was a great showcase. I also want to thank everyone who joined, who saw the showcase in YouTube, and for the lively discussions, for your questions. Oops. I also want to thank Emerald and Josh for the technical support. That was great for having this live stream here. Thank you so much. Without you, we couldn't do this. And I hope we see you next month in April, but at Wiki Workshop. It's an April 24, I think. I shared the link
25th.
25th, I'm sorry, April 25. And you can register, see the latest research on Wikimedia projects. Don't forget to register. We're happy to see you there. There's no showcase in April because of Wiki Workshop. The next showcase will be in May. And with this, I wish you a very good rest of today, wherever you are. Thank you. Bye.